Let's look at some examples from Chapter 8C. So, here's the first example. A card is selected from a standard deck of 52 playing cards, 4 suits, no jokers. Let A be the event that the card is a club, and B the event that the card is a queen. Okay, so for this question, we might not have to draw out a Venn diagram, but I feel like it's good practice to always draw out a diagram anyways. So let's just do that. We know that the number of cards in the deck, the universal set with the sample space here, we got 52 possible options, right? 52 cards in a deck. For Venn A, that was a card being a club. And so if there's 4 suits in a deck, well, that means the deck is going to be split up into quarters. Each suit is going to take up a quarter of the deck. So 52 divided by 4, that's 13. I know that the number of elements in event A, a card being a club, is going to be a quarter of the deck, 13. Number of elements in event B, the card is a queen. Well, there are 4 queens in the deck, one of each suit. So there's going to be 4 outcomes or elements in the set B. Alright, and if we wanted to really fill out this diagram completely, in the intersection there would be 1 card. There would be the Queen of Clubs. That's the only card in the intersection. In B but not A, we'd have 3 cards. All the queens other than the Queen of Clubs. And in A but not B, we'd have 12 cards. Every card that was a club but was not a queen, was not the Queen of Clubs. And so the rest of the cards would be, well, there's 17 cards in this union here. 12, 13, 14, 15, 16, 16. And so we should subtract from 52, 16 to find the remainder of these cards. I'm bad at mental maths, so I'm going to do that on a calculator. 36. So it'll be 36 cards that are neither clubs nor a queen. Okay, so we've got our Venn diagram set out, and like I said, we probably didn't necessarily need to get that done for this question, but it's good practice. So to answer A, find the number of elements in A. Well, there's 13. Number of elements in B, 4. Number of elements in A intersect B, 1. So this is just the information we established in our Venn diagram in the intersection, right? Okay, the probability now. Well, the probability of an event occurring in A, that's just going to be 13 out of the total outcomes or elements in the sample space. Not A. Well, this is going to be 52 subtract 13. It's kind of like the complement of A, right? Over 52. I'm going to have to do that on my calculator again. 52 take 13. It's going to be about 39. Oops. Over 52. And we can simplify these where we can, but let's give all answers. The first fraction that we find to represent the probability and the simplified answer as well. Find the probability of the intersect. That's going to be 1 card out of 52. There's only 1 Queen of Clubs out of the 52. Okay, let me give this answer up here. Okay, so use the addition rule to find probability of A intersect B. Hopefully you remember where you watched the notes video and you saw that probability of A, that's A union B, excuse me. But you saw that the probability of A union B was, probability of A plus the probability of B, subtract the probability of A intersect B. So probability of A union B, let me just write it out in full. So probability of A plus the probability of B minus the probability of the intersect of those 2 sets. Well, we saw that the probability of A was 13 out of 52. And we saw that the probability of B, well, we didn't see it, but we know it's going to be 4 out of 52. And the probability of the intersect, that's 1 out of 52. Probability of A union B is going to be 13 plus 4 take 1. That's going to be 16 out of 52. And if we count up, 12 plus 1 plus 3, there's 16 elements spread out across the union of A and B. So 16 out of 52. 16 out of 52 for C. And find the probability that the card is a queen or not a club. So to really represent what that is asking, we're looking for the probability of the event that the card is a queen. So I believe queen was event B. So is event B, but is not event A. So that's going to be not A or A primed, or the complement of A, or, so union, or is either, so union B. And now if we think probability of not A union B, what region on our Venn diagram is this going to be sort of considering? Well, that's going to be all of B plus all of what is not A. So let's consider what's not A first of all. That's going to be, let me get a highlighter out. That's going to be, well, this border outside region, that's not going to be A. This intersection is going to be A. Of course, this 12 here is going to be A. The only thing else that's not going to be A is going to be this region of set B that does not intersect with A. So that covers not A, right? Everything that is not A we've highlighted. We can see we've highlighted everything except for our set A here. So that's not A, but we're looking for the probability that something is not A union B. So it's not A, or it's B. So let me highlight all of B now. So if I highlight all of B, well, we do actually include this region, this intersect here, that is technically A. So this intersect is not A, right? This is actually part of A. But because we're looking at the union of A and B here, or not A and B here, we include this intersection because it's still B. So it's not A or it's B. So this intersect is or it's B. I hope that makes sense anyways. But what that kind of tells us, it tells us that we're looking at the probability of 1 plus 3 plus 36, these 6, 7, 8, 9, 10, these 40 elements. We're looking at the probability of picking out one of these 40 elements out of our 52. And of course we could simplify that, but I'll leave that to you guys. Alright, so that's one example done. Let's have a look at this next one. So here, we're just given some probabilities. And again, if we wanted to, we could draw out a Venn diagram, but we don't necessarily have to if we don't need to. But we're talking probabilities here, so I'm going to say that the probability that I select an element in my sample space, that's going to be 100%. That's going to be 1. So that's we're talking probabilities in decimals, right? So probability that I pick an element in my sample space, that's going to be 1. Probability I pick an event in A, that's got to be 0.5. And probability I pick an event in B, that's 0.6. Alright, and they give us, they're so kind to give us the union here. 0.75. So I can see that this whole shaded region here is going to be, there's a 75% chance that I select something inside the region as opposed to outside the region. So that means there's a 25% chance of selecting something outside the region. Okay, so we're asked to find the probability of A intersect B. Well, we know from the addition rule that that's just going to be the sum of the probabilities of either set minus probability of the union. Right, so here we count up both sets, and that's the union plus an extra intersect. And we take away the union, that leaves us with just that intersect that we double counted. But anyways, that's going to be 0.5 probability of A, right? Plus 0.6, subtract 0.75. 1.1 take 0.75. Forgive me, I gotta use a calculator. Take 0.75. About 35%. So the intersect, about 0.35. And now we can actually just finish off the rest of this. 0.6 take 0.35. It's 0.25, obviously. And then 0.5, oh god, I'm gonna guess 0.15, but honestly I gotta check that on the calculator too. Alright, so we can actually, just from that, we can finish off the rest of this Venn diagram. Alright, so now we're looking at this guy, probability of not A intersect not B. So we're looking at the probability of finding something that is not A and it's also not B. So if we're looking at what is not A and what is not B, well, anything inside the union of A and B is either A or B, right? So it can't be anything inside that union because we're looking for something that's not A and it's not B. So it can't be either A or B, right? It can't be either of them. So the only thing that, only region that is not A and it's not B is this outside border region. And we saw previously that was 25% or 0.25. So 0.25. Or it's just the total subtract the union, right? And that'll leave us with the border space. But yep. So there's some examples I left you guys here. You can pause here and try them, or you can just find them in the OneNote. The answers are on the OneNote. But yeah, that concludes these examples.